Think we are live. Think we are live. Should be live right now, guys. If anyone's in the chat, let me know. Just gonna leave this question up while we get everything sorted. If you guys want to have a go, feel free to have a go. A-level Maths Paper 3 is tomorrow, guys. For a lot of you, this might be your last exam. So close yet so far. Gonna focus up on mechanics right now. We're gonna do a bit of a mixture tomorrow or tonight even. So yeah, let me know if everything's working, if you guys can hear me. If not, let me know, let me know. Top 10 streams of all time. I'm going to be focusing on rigid bodies, guys. I have three rigid bodies questions because I know a lot of people don't like rigid bodies, so that's what we're going to do. To quickly make the cover for the TikTok live. Give me just 1 second. But guys, feel free to have a go. We're going to start off with a projectiles question. Nothing too tricky. We're going to start in 5 minutes. In 5 minutes, we're starting. Let me know how you guys are feeling as well. More confident for mechanics, more confident for statistics, even. Just let me know. Let me know. I feel like most people, it depends if you do physics or not. Everyone who does physics finds mechanics so simple. Everyone who does stats is a bit the people who do physics find stats a bit worse, but kind of depends. I found most people who just did maths and didn't do any other science, they prefer statistics, so just see how it goes. Both are important. It's not optional. I'm seeing the memes that one is optional, but gotta do both sections. Gotta do both sections. Sorry guys, just setting up that TikTok live stream. Just give me just a second. Apologize. My Wi-Fi completely crashed, so everything went badly. Pax, give me a thumbs up if you're here, because I'll do your question if you're here. But if you're not here, then I'll save your question till whenever I see a thumbs up. So let me know, Pax, if you are here. We starting in just a second, guys. Just a second. I appreciate that, Oscar. I appreciate that. I appreciate that. I know London Maths is doing a 12-hour live stream. That is 12-hour live stream is ridiculous. Just getting the TikTok live up, guys. Feel free to have a go with of the projectile question. Go streamer. I appreciate that, guys. I'm no London Maths, but maybe I'm getting there. I understand it's not the best setup, me going through my written notes, but I don't have OneNote with like an Apple Pen, so if I try to do it on OneNote, all these diagrams are going to be disgustingly messy. So like I want it to be clear enough for you guys, even though my notes are not ideal either. Just starting in 3 minutes, guys. We're starting in 3 minutes. Just getting this TikTok live set up. Feel free to have a go at the question. I will say, guys, with these mechanics questions, we see some repetition. With projectiles, we're always going to do the same thing. Let me know what that thing is, guys. With projectiles, what's the first thing we're thinking with projectile questions? We know with rigid bodies, it's always going to be moments. It's always going to be So what do we have? We have moments, resolve horizontally, resolve vertically. Those three things will always get your answers in those questions. The hardest part is labeling your forces on your diagram. But once you've done that, should be fine. I know no one likes hinges. No one likes hinges. I don't think they really pay attention to it in the spec, do they? They kind of we don't really see any proper questions on it in the textbook. So that's just not great. All right. I think we're all good. Just gonna check the stream is in good condition due to the difficult Wi-Fi earlier. Looks like we're all good. Okay, cool. Alright guys, we're gonna be getting started. Okay, sumat and s equals bt. Yeah, that's exactly it. We split it into that vertical and horizontal, and we're gonna be using suvat for the vertical, and then for the horizontal, because we have constant acceleration, or sorry, no acceleration, sorry. So we have constant speed, so we can just do distance equals speed times time. But let's just go through the question right now, guys. Gonna make sure everything's clear. Okay, let's go. So we're told the particle is projected with a speed of 70 meters per second at an angle elevation of alpha, where tan alpha equals 3/4. I'm immediately thinking when I see tan alpha, we're going to draw out our triangle so we can find sine alpha and cos alpha. So for a point O, which is 70 meters above level horizontal ground, okay, cool. We're also told there's 70 meters above. So we know our vertical displacement is going to be, I always take the downwards as negative, guys. So it's going to be minus 70. But let's go step by step. The particle is moving freely under gravity and first strikes the ground at point A, as shown in the figure above. So as we know, projectile question, split it horizontal, split it vertical. So that's exactly what we do, guys. So first of all, we have that tan alpha equals 3/4. Tan, TOA, opposite over adjacent, is 3/4. So drawing our triangle out, we have 3/4 to be tan alpha. So we know that using Pythagoras, our hypotenuse is going to be 5. Therefore, sine alpha, so opposite over hypotenuse will be 3/5, cos alpha, ca, adjacent over hypotenuse will be 4/5. Now, we know projectile questions always do this. Initial velocity can be resolved into a vertical and horizontal component. Okay? So, just zooming in on our specific initial velocity point up here, we have that initial velocity, as a hypotenuse of 70. To find the vertical component, we're going to do 70 sine alpha because it's the opposite side. Then to find the horizontal component, it's going to be 70 cos alpha because it's the adjacent side. Okay? So exactly that, guys. Projectiles is always the same thing. Now we're going to split it into vertical and horizontal. What are we trying to find? They want us to find the horizontal distance of A from O. Okay, so immediately before we even read the question, we can split vertical horizontal and we can do a little triangle with tan theta, or tan alpha in this case. So horizontal distance from A till O. There's a couple things that we need to fill out in order to find the horizontal distance. So horizontal distance, we want to find the distance. For the horizontal, we know that's going to be speed times time. We know the speed to be 70 cos alpha. We don't know the time. So what we need to do is we're going to use our vertical to find the time when we hit the ground. So we're going to have to work on the vertical first and then use the horizontal. Let's go through it step by step. So always write out what you know with this suvat. I'm seeing we already know that the vertical will be suvat. So here's what we know, guys. The vertical particle is subjected to acceleration. As I said, me personally, I take that upwards to be positive, downwards to be negative. You can do it however you want as long as you're consistent. Okay? So your gravity, minus 9.8, because I said downwards is going to be negative. Horizontal is no acceleration. We have that constant speed. Okay? We can connect these two by time. That's what we're doing whenever we see these projectile questions. So looking at the vertical, we use suvat. So what do we know? A displacement, minus 70. Remember, guys, I said, going back to the question, I said that I'm going to take the downwards direction is negative. So it's not 70, it's minus 70 because we're going from this platform down to the bottom. So just looking vertically, we're going minus 70 down. Our initial speed we said was 70 sine alpha. We know sine alpha equals 3/5. So we can do 3/5 multiplied by 70. That just gives us 42. So we have our initial velocity vertically to be 42. Final velocity we don't particularly care about in this question. Acceleration is minus 9.8. We have to find the time. Remember, guys, we're finding the time so we can multiply it by horizontal speed when we do the horizontal part so we can find the distance traveled horizontally. Because that's what we're trying to find, A to O horizontally. Okay? But for now, let's just find the time it takes for us to land. Then we can use that time. So we're using S equals ut plus half at squared. We have S, we have U, we have A. So we're going to find t. We can see we're going to form a quadratic as we do, or as we tend to do in these questions. So just plug in the values. S is minus 70, U is 42, A is, so we have half times minus 9.8 is minus 4.9, and we have t squared. This is a quadratic. You can add over that 4.9 t squared, take away that 42t, put it in your calculator, guys. What's up, Fred? What's up, Fred? We're doing projectiles. Put it in your calculator. Quick recap, guys. This is the projectile question for anyone who's joined. We found the vertical and the horizontal component. We're trying to find the distance horizontally from our point O to A. Just quick recap for anyone who just joined. I'll see you there, Fred. Okay, so we form a quadratic, add over the 4.9t squared, take away the 42t. From here, slap it in your calc, find two different values for t. We get t equals 10 and t equals minus 10 over 7. We can't have a negative time, so our time will have to be 10. So that's the value of t that we take. Okay, this is great. We've done the vertical, we found the time. Let's look at the horizontal. We care about the distance. What do we have? We have the time, and we also have the speed. We have the horizontal speed to be 70 cos alpha. Going back up, guys, I'm going to keep relating back. Because we put it in that horizontal and vertical component, yeah, projectiles is quite nice. I'll say that. It's very repetitive. We have that 70 cos alpha. We know that cos alpha equals 4/5. So we have the initial speed, which will remain constant throughout because there's no acceleration. So we have that initial speed to be 56, 70 times 4/5. Then we have our time is 10, which we found from the vertical because that was the time it took for us to get that displacement of 70, or minus 70 in the way I did it. Exactly 56 times 10, 560. Pax is on it. I see Pax is here. Pax, do you want me to go through the question you wanted now, or can I just do it in order? Because otherwise your question will be lost. I'm going to put on the next question up while I while I wait for a response. Oh wait, yeah, we still have this. We still have part B. But Pax, answer that if you want. Okay. So the particle is moving freely under gravity and strikes the ground at point A, as shown in the figure above. The next part B, sorry, we have to show that as the particle reaches A, it hits the ground at 45 degrees. So we're trying to find the angle that it hits the ground. Same thing as always with projectiles. We're going to find that vertical component and the horizontal component. But this time we have to find the final velocity because we want the velocity when it's hitting the ground. Okay? So here's how we're going to do it, guys. Sometimes it helps to draw it out. Okay? So we need to find the final velocity for both components. Yeah, Pax, I'll do it after part B. Um, we need to find the final velocity for both components. We have the horizontal to be constant speed. A horizontal is always going to be that 56 or that 70 cos alpha. So yeah, because cos alpha is 4/5. Okay, so we know a horizontal speed, so that's completely fine already. All we need to do is find the final vertical speed. Now I know a lot of you guys will potentially draw your vertical over here where I have my cursor, but it makes it easier to visualize what we have to do if you draw that vertical here. Because we have our vertical here and a horizontal here, and we want to find tan alpha. Exactly, yeah. Final velocity vertical over the horizontal. Exactly, that's exactly it. We use that tan theta, or okay, it should be alpha maybe, it doesn't matter. Tan theta equals our final velocity vertical, the opposite over the adjacent, which is that horizontal. So we have the vertical over the horizontal. To find the vertical, solve that again. We know that u is 42 from before. Acceleration is minus 9.8. Our time is 10. What can we use? We can use v equals u plus at. So that's simply going to be 42 is our u. Then we have minus 9.8 times 10, because it's minus 9.8 times 10. So that's 42 minus 98. That gives us minus 56. That minus 56 is because we're going downwards. So just the velocity, sorry, is just going to be 56. Okay, minus 56 is telling us the direction. So it's just going to be that 56 is our velocity going downwards. We can keep it consistent here. So therefore, we have 56 as our vertical final speed, or final velocity, sorry. And then our horizontal is also going to be 56. So we're going to have tan theta equals 56 over 50, or over 56, okay? Tan theta equals 56 over 56. That's just tan theta equals 1, 56 over 56. Then we're going to find the inverse tan of 1, or arc tan of 1, and that's just 45. So we've shown that it's a 45-degree angle. Why is 9.8 negative? Because I've decided that my downwards is going to be negative, okay? As long as you're consistent, if you take all of your upwards as positive and all of your downwards as negative, that's fine, or you can do the other way around, as long as you're consistent throughout the question. Because it's a vector, it has a direction. Yeah, exactly. All right, Pax, I'm going to do your question. I'm going to do your question. It's the ladder with a peg, I believe. I'm going to leave it up for just a second. The first part, we took upwards to be positive. Wait, which part? Which part? The first part, horizontal distance from of A from O. Yeah, I decided to take upwards as positive. Wait, which part? Which part? The chat is really slow for me, so I'm gonna leave the working up potentially while I wait for the chat to just load up. Wait, part B, first part. So to find the angle that we're hitting down, yeah, that we're hitting the ground at, we're gonna have to find the vertical and horizontal components. Okay, yeah, we have to find the vertical and the horizontal components to then find that angle. Okay, so then we're gonna redraw. So imagine that particle, or was it a particle? Yeah, smashing down into the ground. In order to find that angle, if we can split it into vertical and horizontal, it's always the same thing with projectiles: vertical, horizontal. Then we can find the angle. Now I know you guys will probably draw this vertical where I have my cursor here, but just to make it obvious that you can use that tan theta, in this case I label theta, is the vertical over the horizontal. We can kind of redraw this vertical component of our final velocity over here, makes it even clearer that it's going to be the opposite over the adjacent to get tan of our angle. And then we use the suvat from before to find that final speed vertically. We know the final horizontal speed is going to be the same throughout because we have that constant horizontal speed. It's always going to be 56. So all we have to do is find the final speed of the vertical component, and then we can just use the formula. You can just remember this going into the exam. Yeah, I would recommend it potentially. That tan theta equals the vertical over the horizontal. Does that make sense? I'm going to leave it up on the screen just for a second. I will say, guys, if you left it as negative, that minus 56 as negative, I just checked now, it would give you minus 45. But yeah, like you'd have to the juice, it's the positive, wouldn't you? Because that is the speed, sorry, that we're going down. Not the speed, sorry, that's the velocity. Perfect, thanks. Okay, cool. So we are going to take the positive, guys. Like, do you think logically in these questions, if you had already been taking the positive as downwards, this would be 56 and 56, and then you can just find the angle there, because we do need a positive angle as well. Okay, Pax, I'm going to do your question. It's a rigid bodies question. Actually, believe I have this. Yeah, I do. I do have it like this, so I can kind of highlight the forces as we go. Okay. All right. So we're told the ladder AB has mass M and length 6A. So they show us the length. Not sure if it's uniform yet, but let's just go step by step. The end A of the ladder is on rough horizontal ground. Rough ground, we're gonna have friction. Let's find out if friction is at its maximum. Let's kind of see that first. I have a hinges question as well. I do have a hinges question. It is a past paper one, but it's always the same logic with hinges. So the end A of ladder is on rough horizontal ground, we're gonna have friction. The ladder rests against a smooth horizontal rail at the point C. Smooth, no friction. Very nice. The point C is a vertical height 4A above the ground. Okay. The ladder rests against a here we go. The ladder rests against a fixed smooth horizontal rail at point C. The point C is at vertical height 4A above the ground. The vertical plane containing AB is perpendicular to the rail. Remember, guys, there's a lot of waffle in these questions. Zoom in a little bit. Got you. Cool. So, where were we? The ladder is inclined to the horizontal at an angle of alpha. So we have an angle alpha here, where sine alpha equals 4/5. They tell me sine alpha, I'm immediately thinking draw out that triangle, find cos alpha, maybe even tan alpha if we need it, but normally it's just going to be for cos, as shown in figure 1. The coefficient of friction between the ladder and the ground is mu. The ladder rests in limiting equilibrium. Guys, what does limiting equilibrium mean? Like when we see limiting equilibrium, point of slipping, point of tilting, or we're accelerating, what does this mean for our friction? The ladder is modeled as a uniform rod. A uniform rod, perfect. We know that this mass of ladder will be halfway of our length. Okay, it's going to be in the middle. So we know the whole thing of the rod is 6A. So our mass, that center of mass, is going to be in the middle. So it's going to be 3A. So let's start going through all the forces, guys. I'm going to go through step by step. What they want us to do is show the magnitude of the force exerted on the ladder by the rail at C is 9 mg over 25. F max, F equals mu r. Perfect, perfect. So our friction will be mu times r, where r is our reaction force at A. What I'm going to do now is I'm going to compare the diagram we've drawn out, showing you guys every force I did, and highlighting as we go, okay? So what do we know? The mass is m, and it's a uniform rod. So 3A up our rod, 3A up our rod. So you can see we have 3A, we're going to have that force mg, because we have a mass of m, then F equals ma, so it's going to be mg. This stuff should be natural. When you see mass m, we know it's going to be mg force at the center. Okay. So what else do we know? We're on rough horizontal ground, so we know we're going to have that reaction force on the ground, and we're also going to have mu times r. Because think about it, guys. Your ladder's currently like this, with your peg. So which way is the ladder potentially slipping? Which way are we stopping it from slipping? Well, the ladder's trying to go down like this. It's trying to slip down like this, guys. If you have a ladder on the wall, it's not going to go up, is it? It's going to try to slip down. So our frictional force will be preventing that ladder from slipping down, going going inwards. Yeah, we're preventing that ladder from slipping down. Okay, so mu r will be going towards the wall. Okay, moving on. What else do we have? So C is a vertical height 4A. Okay, fine. Vertical plane. Okay, okay, okay. So immediately we drew out that sine alpha equals 4 over 5, guys, with the triangle. So sine alpha equals 4 over 5. The opposite, so opposite over hypotenuse is 4 over 5. From there, we know that the other side will be 3. You can use a bit of Pythagoras. Always know this triangle of 4, 3, and 5, guys. Same with 12, 5, and 13. It's kind of good just to know it very quickly. How can you show the top angle is alpha? Yeah, yeah, we're getting there just a second. We're getting there just a second. I will address that. So we saw it was limiting, so our friction will be mu r. And then what do we do in these kind of questions, guys? We always do moments, resolve vertically and resolve horizontally. It may not be in that order, but normally it is moments and then one of the other two. So let's go step by step. Do we have all the forces? I addressed the R, I addressed mu R, I addressed mg. Okay, we also know we're going to have a reaction force at our peg C, or what do they call it? A rail C, doesn't matter. Peg, rail, whatever it is. We have this reaction force, let's call it N, okay? So what do we know? Well, we know as well, we can find the vertical and the horizontal components at N. The reason we know this angle is alpha, so what I'm going to do, guys, is I'm going to draw a triangle and I'm going to show you why it's alpha. So we have this triangle right now going here. We know, imagine this right angle, we have a right angle here. we know that this angle is going to be 90 minus alpha, right? Because everything inside the triangle must be equal to 180. So we have our, where we go? We have our 90, we have our alpha, and we have 90 minus alpha. Therefore, we also know, what else do we know? We know that that whole, what have I done? I think we're fine, okay. We also know that this whole side here, this whole straight line here, where we had our triangle going down, all of this will be 180, right? So what do we know? We know this is 90. We know this angle here is going to be 90 minus alpha. The whole thing is 180. That's a horrible 90 minus alpha. So this angle here is going to be 90 minus alpha. This is 90. So this has to be alpha for the whole thing to be equal to 180. Okay, so if in doubt, put your angle as alpha. But that is the explanation of why this angle is alpha. I hope that helps. Because we have this whole straight line must be 180. We know this is 90 minus alpha because of this triangle that we have beneath. Where's my mouse gone? Beneath here. And we know this is 90 because this force is going to be perpendicular to our, is it a beam, a rod, whatever it is in this question. And then we have our reaction force N, and the whole line is 180, so we have the angle alpha. I hope that makes sense. I hope that makes sense. So we know from here we can split it into the vertical and horizontal forces, because as we know, in moments we're going to be using rigid bodies, vertical and horizontal. Okay, when it's particles, we're going to use perpendicular to the plane and parallel to the plane. But in here, we're just going to do general vertical, general horizontal. So looking at the opposite, this is going to be n sine alpha, and then because we have the adjacent to our angle, it's going to be n cos alpha. Let's start moving on. So as we know with these questions, normally we're going to do moments first. Why are we going to do moments? Whenever we want this reaction force at n here, we use the moments because we don't know r or mu r. So remember guys, moments is force times perpendicular distance. So if the perpendicular distance is 0, then we're going to be able to eliminate certain forces. And exactly that, both r and mu r have a perpendicular distance of 0, so we can eliminate them when using moments. This will allow us for our only unknown to be this reaction force N. So let's go through that, guys. So they want the reaction force N. We're going to take moments about A, so we can ignore r and mu r. We're taking moments about A, so let's see what forces we have and what perpendicular distances we have. So the hardest part for me is the clockwise, anti-clockwise thinking. So going anti-clockwise, we have N as a force, and the perpendicular distance from our point A is going to be this distance here. So what do we know? We know this side is 4A, and we have this angle here, right? So as here, so sine alpha, we have our opposite is 4A, we won the hypotenuse. So sine alpha is going to be the opposite over the hypotenuse. I called X the unknown. I'm going to call this X. So this is our unknown side. So 4, it should say 4A, shouldn't it? Yeah, let's just say 4A over X equals sine alpha. 4A, guys, 4A. 4A over X equals sine alpha. We just want X, so we can divide over. So sorry, we can multiply over by our X and then divide by our sine alpha. So we get that X equals, quickly making this clearer, is 4A over sine alpha. Okay? Nothing scary there. So we have a perpendicular distance to be 4A over sine alpha, and our force is N. What is the other force? The one countering it. Countering it, we have mg, our force going down. They're the mass of our, is it a rod? What is it? The mass of our ladder going clockwise. Okay? Hope this is making sense, guys. Give me any questions if this is not making sense, okay? So going clockwise, we have mg. The perpendicular distance to mg, it's going to be this distance here. So what's that going to be? What's that going to be, guys? It's going to be 3a times by cos alpha. Why is it 3a cos alpha? We have the hypotenuse, which is 3a, and we know this adjacent is going to be cos alpha. So perpendicular distance will be 3a cos alpha because we have the hypotenuse. We want the adjacent, so we do the hypotenuse multiplied by cos alpha to get the adjacent side. Pax is happy, cool. So we have n times 4a sine alpha equals 3a cos alpha mg because we are in that limiting equilibrium. We are stable, the moments must be equal here. Therefore, otherwise we would start rotating either way. So rearranging because we want to find n. We know sine alpha to be 4 over 5. We know cos alpha is 3 over 5. Nice. And I believe that's it. So we have sine alpha, we have cos alpha, so we can just divide over by so multiply by sine alpha, divide by 4a, plug it in your calculator. We can see it as well that this a here will cancel out with this a here as we're dividing over by 4a. So our a's cancel, we're left with 3 times 3/5 mg multiplied by 4 over 5. Put in your calculator gives you 9 over 25 mg. So all we're doing is finding moments about A to eliminate these two forces that we don't really like and don't really know in order to find n, because that would then be our only unknown. And we don't have to use this n sine alpha and n cos alpha just yet, because we don't care about the vertical and horizontal just yet. Right now we're just finding moments. Part B is the hard bit. Okay. Let's go to part B. So hence or otherwise, find the value for mu. So as we know, what have we not done yet? We haven't done horizontal and we haven't done vertical, so that's what we're going to be doing. Just going to go back to my blocks. Cool. So what have we not done? We haven't resolved vertically and haven't resolved horizontally. Okay, so let's resolve horizontally. Let's look at our diagram. What do we have going horizontally, guys? What do we have going horizontally? So going horizontally, these must be equal. We have n sine alpha. Do we have anything else going to the left? I do not believe so, but we have going to the right mu times r. Okay, so n sine alpha equals mu times r. If that's me, okay. So mu times r is n sine alpha. We know what n is to be 9 over 25 mg, and we also know sine alpha. We found n and we know sine alpha. Okay, then going vertically, let's go back to our diagram. What do we have going vertically? Okay, going vertically, we have going up, we have r, and we have n cos alpha. Then going downwards, so sorry, upwards is r n cos alpha, then going downwards we have mg. Okay, so it's going to be r plus n cos alpha must be equal to mg. Once again, we are stable. That ladder is not moving, so these have to be equal. Okay, there we go. So we have r plus n cos alpha equals mg. We know n, we know cos alpha is to be 3/5 using our triangle from before. So just plug in everything to be n equals 9 over 25 mg, cos alpha equals 3/5. So we have r plus, just plugging in 3/5 times 9 over 25. There's 27 over 125 mg to be equal to mg. All we have to do, we want to find r. Because remember, guys, what we're trying to do, we're trying to find mu, right? So if we can find an expression for r, so mu is the only unknown, we're going to be able to find an expression for mu from that. Okay, so we're able to find something to be r that we can then substitute into this horizontal equation. It's always the same stuff with rigid bodies. Horizontal, vertical, and then potentially sub something back in so we can find our unknown. Always the same pattern, guys. It's disgusting what they do here. Okay, I'll explain the length in just a minute. I'll finish the question and then go back. So R equals 9 over 125 mg, because we do 1 mg minus 27 over 125 mg. We plug this into a horizontal one, so we have mu times 998 over 125 mg to be equal to 36 over 125 mg. The mg's will cancel, so we just do 36 over 125 divided by 98 over 125. That simply gives you, or you can do multiply by 125 over 98, it's the same thing. Put it in your calculator, gives you mu equals 18 over 49. Okay, I'm gonna go over why it was, okay, yeah. So the question was, can you explain the 4a over sine part again? Yeah, I can indeed. Let's go back to our, there we go. So what we're trying to find with the moments, we wanted that perpendicular distance to our reaction force n. The perpendicular distance, because this line goes like this, oh Jesus, because this n force is like this, the perpendicular distance to A would be like this, right? So we're trying to find that hypotenuse. We want this hypotenuse here. All we have to do is a little bit of trigonometry. We know our opposite is going to be 4A. We want the hypotenuse. Opposite, we want the hypotenuse. So we know that sine of alpha will be equal to our opposite 4A over our hypotenuse, which is what we want to know. We want to know x, okay? So from here, because we want to know x, we know that 4a over something, the thing we want, the perpendicular distance, will be equal to sine alpha. From here, just rearrange for x. We multiply over by x and divide by sine alpha. So we're left with 4a over sine alpha. That's how we know it. It's just trigonometry. Just have to stay calm in the exam to find the distance that you want. One more for n. So for n, because it's smooth, we don't have to worry about any friction or like that. The only reaction force that we have is n. And because our ladder will be leaning like this and we have that peg here, it's going to be a reaction force perpendicular to our ladder. Okay, it's not going to be vertical because the peg is pushing up like this, pushing up perpendicular. Okay, so we have n. And then which part do you want me to know? We know this angle is going to be alpha. So if in doubt, call it alpha. Why is it alpha? Because we can build this triangle here. We know that this is a 90-degree angle. We know that this angle must be 90 minus alpha. This is going to be 90 here. So we have 90 here. Oh, I probably shouldn't do this highlighting. We have 90, oh, yo, yo, 90 minus alpha here. And then, because this whole straight line must add up to 180, so all must be 180, right? So either side is going to be 180. We know that this line, so we have 90, 90 minus alpha, the missing one is alpha, right? From there, we can just use our adjacent and adjacent opposite rules. The side adjacent to our angle is going to be n cos alpha, and the side opposite is going to be n sine alpha, because our force is n, and we can use, so same idea here, guys. We have the hypotenuse, and we're trying to find the opposite, and the adjacent is just trigonometry. So we have the opposite to be n sine alpha, adjacent to be n cos alpha. I'd recommend in the exam just knowing when you have the one adjacent, it's going to be that force times by cos alpha or cos theta, whatever it is, and when you have the opposite, it's going to be n times sine alpha. Can we leave it in fraction form? In this paper, they left it as fraction form. But in general, with mechanics, three significant figures. Probability, or sorry, statistics, they don't particularly care. You can do four or three, whatever you want. Decimal places, significant figures. Whereas mechanics, three significant figures, or they kill you. Yeah. I believe maybe in this question they wanted an exact value or something. Find the value of mu. They didn't specify. I don't know. In the answer, they left it as the fraction when I saw the mark scheme. But I don't know. I don't know. It's a good question. But I know in general, three significant figures. They're not going to take marks away if you do three significant figures. So about the fraction, not 100% sure, but do three significant figures in general. All right, boys. Do you guys have a preference on the next question? I saw some people wanted the hinges, but I kind of want to mix it up a bit, not just do rigid bodies. Because we did two. Oh no, we actually have another rigid bodies question. This is quite similar. Yeah, I'll go for the hinges. We'll do the hinges. This is a 2018 question. Okay, wait. Yes, that makes sense. Okay, so but there is no weight for n, right? No, there's no weight because we're thinking about the ladder, right? We don't care about the peg, yeah, or the rail or whatever it is. We care about what is happening to our ladder because of that peg. What's happening to our ladder? We're having that force pushing upwards. It's preventing that ladder from going down, so we're having that force pushing that ladder up. Okay, it's just about thinking what it's doing to the ladder, and you can put in that reaction force. I hope that makes sense. Okay, let's do hinges, guys. We're here now, so let's do hinges. Nice. You're the doctors, you're playing me out loud. Great, great to hear. I'm gonna make sure the stream's all good before we carry on. Okay, cool. I'm happy to happy to hear that the doctors are gonna be hearing me. Okay, let's do hinges. Let's do hinges. All right, loads of waffle. All right, let's go. Let's go. Let's go. Actually, I'm gonna do this on OneNote. So here's our hinge question. So we have this little diagram here. Let's zoom in to make it perfectly clear. All right, cheers, Pax. The plank AB of mass M and length 2A rests with its end A on the rough vertical wall, guys. With these, do not stress too much. Yeah, do not stress too much about the rough. The key thing is at our hinge A, at our point A, we're gonna have a vertical and a horizontal force. This will be the case whether we have friction or not. I'm gonna show that we're gonna label our frictional force just as y. You could label it as mu times r. It doesn't particularly matter. The only reason we care about friction in general is if they want you to eventually find mu. Okay, because you're gonna have to use that reaction force going into our, what is it, a rod, a plank at A. Okay? But let's just go through it. So don't worry too much about friction. Just remember at the hinge A, we're going to have a vertical and a horizontal force. The plank AB of mass M and length 2A rests with its end A against a rough vertical wall. The plank is held in position by a rope. Nice. One end of the rope is attached to the plank at B. Okay, cool. And the other end is attached to the wall at C. Okay, nice. Which is vertically above A. Perfect. A small block of mass 3m, okay, that's going to be here, is placed on the plank at the point P where AP is X. Amazing. So we already know we're gonna have 3 mg. There's a couple things we already know. But let's just read the whole question first. The plank is in equilibrium in a vertical plane which is perpendicular to the wall. Okay, in equilibrium, we're not limiting or anything like that. So we're actually not even thinking about friction being at its max. It's not limiting equilibrium, so we don't even have to worry about that here. I just wanted to introduce the idea of friction in hinges, and just to know when it's like just to know that you're going to be having that vertical or downward force, either one. Upwards or downwards force at point A. Okay, here it's not even limiting, so we can't even use mu r. So let's not worry about that. It's in equilibrium in a vertical plane which is perpendicular to the wall. The angle between the rope and the plank is alpha. Tan alpha is 3/4. Immediately, I'm drawing that triangle. I'm not even wasting my time. I'm drawing that triangle so I can find sine alpha and cos alpha. Okay. Shown in figure 3, the plank is modeled as a uniform rod. Okay, uniform rod. So we have that massive M. So let's compare to my diagram right now. Two things that we can immediately label on, guys, are the masses, the forces of the masses. So we know the whole length is 2A. We know it's a uniform rod. Block is modeled as a particle, and the rope is modeled as a light inextensible string. Light inextensible string, all it's telling us, constant tension throughout. Yeah, this is hinges. Constant tension throughout. And if we had connected particles and it was going to be acceleration, the acceleration would be the same of both our particles. But we're not doing that here. So key thing is constant tension throughout, in case they ask that as a one marker. So immediately, mass m, and the block has mass 3m, and we know their distances. We know one is going to be uniform, so it's going to be a away from point A, halfway from A to B. And then with 3m, we don't know the distance, we can call it x. So immediately, what forces can we draw on? We can draw on this mg, a away from A, and we can also draw on this 3mg, which is going to be x away from A, right? So we can immediately draw that on. We also know the rope is holding up our, I keep forgetting guys, plank. So we can have our tension on our rope. Okay, we are eventually gonna have to do this in vertical and horizontal because I'm gonna keep on saying it, guys. Rigid bodies, moments resolve vertically, resolve horizontally. It's always that. It makes me sick. Yeah, it's the same pattern over and over and over. Okay, so if you know that, and the only tricky part is to label the forces. The method is always the same. Okay, the forces can be the tricky part. So what do we have now? They want us using the model to show that tension in the rope is 5 mg multiplied by 3x plus a over 6a. Okay? So what can we do? What can we do? Well, we know that our hinge A, as I mentioned before, is going to be on against a rough wall. We don't particularly care, but that hinge is going to have a vertical or a downward force, sorry, upwards or a downwards force, and then we have pushing in to that plank, right? So we have pushing in, that reaction force X, and we have Y, which can be up or down. I mentioned this in my video yesterday. It doesn't matter whether we put it up or down, okay? If we put it up and we get a negative answer, that means it would have been going downwards. If we put it downwards and we get a negative answer, that means it wouldn't be going upwards. The reason it can be going upwards or downwards, I've said it in my video, I'm going to say it again, is if that string was so tight, it wanted, yeah, Oscar's already got it. If that string was so tight and it was trying to make our plank go upwards, that reaction force at our hinge would have to be pulling it downwards, so it's in equilibrium. However, let's say our plank was so heavy that it was trying to go downwards, that hinge would have to be pushing it upwards to prevent that plank from going downwards. So we don't know which direction Y is going to be, but we'll find out in our answer. In general, I tend to put it up, but it doesn't particularly matter. So we don't have to worry about this t cos alpha, t sine alpha yet. I'll explain that in a minute because we're going to be doing moments first. Whenever they want you to find, in this case, it's going to be a tension, I believe. We have to show the tension. We're going to have to eliminate, so we want t. We're going to have to eliminate other unknowns. What are two obvious unknowns that we really don't want to be involved? It's going to be y and x. Okay? We don't want y and we don't want x. Okay? Actually, I'm going to quickly explain this t cos alpha, t sine alpha. So this t cos alpha, t sine alpha. Remember, guys, this horizontal, essentially these are the different components of our tension, right? Thinking about the horizontal, we know that this angle is going to be alpha. Why do we know this angle is going to be alpha? Because, oh, I lost my mouse, okay? Because this angle, using z angles, they're going to be the same, right? So from here, it's just a little bit of trigonometry. The opposite is going to be t sine alpha. The adjacent is going to be t cos alpha. But remember, guys, very key thing, this t cos alpha will not, in fact, be up here, okay? This t cos alpha is going to be down here. Therefore, its perpendicular distance to A will be 0, because it's going to be in line with A. I'm only drawing out like this just to make it perfectly clear where we get our values for this horizontal and this vertical component, and using this angle of alpha. But in general, this will be on the same going through A, so our perpendicular distance will be 0. That's very key. So what we're going to do is we're going to find the moments about A, because we don't want to involve Y or X, okay? We just want to involve the things that we know, and the only thing we have to find out is T. So if we can get things with the only unknown being T, that is perfect. Oscar said it ages ago. So they just want the tension, so we're going to take the moments about A, okay? So as I said, in these questions, we do moments, resolve horizontal, resolve vertical. It's always going to be all those three things throughout the question, okay? So the moments at A, let's think about it. What is taking us, the hardest part? We're taking clockwise. So what's going clockwise? We have this mg and this 3mg. The perpendicular distance to each. So to our mg, we established it's going to be A away from A. And the perpendicular distance from 3mg, let's change colors, the 3mg will be x, okay? So our clockwise moments, remember it's in equilibrium, so our moments clockwise and anti-clockwise will be equal. So we have A times mg plus x times 3mg will equal, so what's taking us anti-clockwise? Anti-clockwise, remember we don't account t cos alpha because the perpendicular distance is 0. But we do have this t sine alpha taking us anti-clockwise, okay? So what's the perpendicular distance to t sine alpha? That's all the way at B. So that's going to be, we have our A and we have our 2A. So we're going to have that 2A multiplied by t sine alpha. Okay? From here, they want us to find the tension, so we're going to have to make t the subject. Now here's the thing, guys, we already know sine alpha. We drew that triangle because what did they tell us? They told us that tan alpha was 3/4, right? Tan alpha was 3/4. So we drew our triangle. Sometimes I forget to mention these parts because it's the same in every question. We have our opposite to be 3. So TOA, opposite is 3, adjacent is 4. We know by Pythagoras the other length will be 5. So we know that sine alpha, SO, opposite over hypotenuse is 3/5. And we know that cos alpha, CA, adjacent over hypotenuse is going to be 4/5. Okay? So we know those two things for sine alpha, cos alpha. So then making t the subject, we have this sine alpha to be 3/5. And then we have anything else that we know? No, that's all we know. So all we have to do is we have factor out this mg because in the show that they wanted mg factored out. So factor out this mg. So we have mg times by a plus 3x or 3x plus a to make it look like their answer. In mechanics, they are horrible, guys. They want your show that's to look exactly like they write it. Otherwise, they take marks away. It's disgusting. But so write it out as they have it. So we have this mg, then we have 3x plus a. Then we have 2a multiplied by multiplied by sine alpha, which is 3/5. All we have to do, so what do we have? We're going to multiply through by 5, then divide by 2 times 3, which is 6. Well, 6a. So we're dividing by 6a, multiplying through by 5. That leaves us with 5mg times by 3x plus a, all over 2a times 3, what we have up here, which is just 6a. So we have the t equals 5mg over 3x, 5mg times 3x plus a over 6a. I hope that makes sense. Let's move on to part B. So guys, what have we done? We've done the moments. There's two things we have to do. Resolving horizontally and resolving vertically. Okay? We're told the magnitude of the horizontal component of the force exerted by the plank at A by the wall, that's a disgusting sentence, is 2mg. All they're saying is this reaction force at point A is this x will be 2mg. So they give us a horizontal thing. Guess what, guys? We're going to be going for the horizontal resolving. Thumbs up if everything is making sense so far. Thumbs down if it's not making sense. Okay, so we know that x is 2mg. First reaction that I'm thinking, let's resolve horizontally, okay? So let's do it, guys. There we go. Let's resolve horizontally. So actually, let's go back for a second. What are the horizontal forces? Well, the only horizontal forces that we have is x, which we now know to be 2mg. And what else do we have as a horizontal force? Nothing over here. We have this t cos alpha, right? So our x must be equal to t cos alpha. So let's do that here. And what do they want? They wanted x in terms of a. So let's just resolve horizontally. Oscar's happy. Resolve horizontally and see if that will get us anywhere. So horizontal, we have x equals 2mg, x equals t cos alpha as we established. So 2mg, cool. Everyone's happy. So 2mg equals what we had for t, which we found in part A. If you couldn't do part A, you can use that answer for part B, which is 5mg times 3x plus a over 6a. And we times this by cos alpha, which we had from before using our triangle to be 4/5. We can see cancelling out either side. Amazing. Cancelling out either side. We can have these mg's cancel. And we can also have 4/5 times by 5 over 6 is 20 over 30. 20 over 30 is 2 over 3. That's where we get the 2 over 3 from by just plugging this in the calc. 5/6 times 4/5. So we have 2mg cancelling out on either side. So they want x to be the subject. Looking back at the question, guys, they want x in terms of a. So x must be the subject of our formula. So we have that x equals, going back, okay, cool. Because the mg's cancel, we have that 1 equals 3x plus a over 3a. We want x to be the subject, multiply over by 3a. So we have 3a equals 3x plus a. I'm going to take away a from the left-hand side. 3a minus a is 2a. We have 2a equal to 3x. So our x value will be 2a over 3. Amazing. Let's go on to part C. So just a bit of rearranging once we cancel out those two mg's. It's always just using the same stuff, guys. It's very, very repetitive, but so what have we not done? We've resolved horizontally. We found the moments. One thing left, resolve vertically. So I have a feeling we're going to have to do that for this question. You can kind of just already do it before the question starts, to be honest. The force exerted on the plank at A by the wall acts in a direction which makes an angle of beta with the horizontal. So let's quickly draw out what that looks like. So we know x is 2mg, but just bear with me here. So we know we're going to have this force, essentially, because we're taking a horizontal component and our vertical component, and we're told that it's going to make an angle of beta with the horizontal. So what can we do? What can we do? If we find the vertical and we find the horizontal, I do have this written out clearer on my notes. If we can find the vertical y and the horizontal x, we can do tan opposite over adjacent. So tan beta will be our y over x, and that's exactly it, to find tan beta. So I do have this out written out a little bit neater. So let's go through that now. If it lets me. There we go. So we're going to resolve vertically, guys, to find y. Because if we find y, then we can work. Exactly that, guys. We want to resolve vertical now. It's the last thing we have to do. We know that tan beta will be y over 2mg, which we found to be x. Resolving vertically, let's look at our vertical forces. What do we have going vertically, guys? What do we have going vertically? We have t sine alpha. We have our y. So it's going to be t sine alpha plus y. That's what we have going. I keep saying vertically, going upwards, yeah? And then going downwards, we have mg and 3mg. So t sine alpha plus y will be equal to mg plus 3mg. That's just 4mg, okay? So y plus t sine alpha will be equal to 4mg, I believe. Yeah, t sine alpha plus y equals 4mg. Luckily, we know t and sine alpha. We're trying to find y, so we make y the subject of the formula. So we have y equal to 4mg, take away t sine alpha. Let's look back at what we know. We know that t is 5mg multiplied by 3x plus a over 6a. And we know that sine alpha, he says, sine alpha is 3/5 from our triangle before. Okay? But here's what we're going to use, guys. We don't want x in our answer. X is this unknown thing. And there's a reason they wanted us to find x in terms of a. There's a reason they wanted us to do this. We're going to use it here. We know that x equals 2/3 a. So we're going to make that substitution. Okay? First of all, guys, with these kind of questions, A's and MG's do tend to cancel in general, but if we have an X there, we won't be able to cancel anything. So to get everything in terms of A and then looking for A's to cancel kind of gives you an incentive on what to do in these questions. And also, it was also what they mentioned in part B, and we have to resolve vertically. Putting all the pieces together will help you go in the right direction. It can be a bit tough to see, but once you know the pattern, there's only one thing that you can be doing. So X equals 2/3 A. We have 3 times 2/3 A, well, the 3's cancel, so we just have 2a as our 3x, okay? So, looking at here, guys, we have our 5mg, instead of 3x plus a, we now have 2a plus a, that is just 3a, all over 6a times by 3/5. 5 in the numerator, 5 in the denominator, these cancel. So we're left with y equals 4mg, take away mg times by 3a over 6a. Our a's will cancel, perfect, we did not want a in our answer. So we have, what do we have? 4mg, take away 3 times 3. So 4mg minus 9mg over 6. 9 over 6, that is just 3 over 2. So we have 4mg, take away 3 over 2mg. Great. Y equals 5 over 2mg. So we have y. We know x is 2mg. Looking back here to find tan beta, and then going all the way back up to the question, what do they want? They actually wanted tan beta, so we don't even need to just find beta. We can find tan beta. So we know tan beta will be our vertical over the horizontal, opposite over the adjacent. And we now know y to be 5 over 2mg. So we have 5 over 2mg divided by 2mg. The mg's cancel. 5 over 2 divided by 2 is 5 over 4. So the tan beta equals 5 over 4 because the mg's cancel. That's exactly it for part C. Let's go to part D, I believe. Is there a part D? Okay, cool. So we're told the rope will break if a tension in it exceeds 5 mg. If the tension is greater than 5 mg. Okay, so what we already thinking? We know what tension is. We know tension in part A. They tend to give you these things in part A so you can keep working through the question in case you can't find it. So we know that all of this must be less than or equal to 5g. Because it says if it exceeds 5g. Yeah, exceeds 5g means we can include 5g. Explain how this will restrict the possible positions of P. Justify your answer. So what is P? P is where we put that small block. So the positions of P will be x away from A. Okay? Exactly, we're trying to find the maximum value that we can do of x. So what do we know? We know t must be less than or equal to 5mg, so all of this must be less than or equal to 5mg. So let's just plug it in and see what we get for x, our restriction on x, because that is what we care about. Exactly right, we're trying to find the restriction of x. So t must be less than or equal to 5mg. T equals 5mg 3x plus a over 6a. Amazing. We're going to leave x this time because we're trying to make x a subject. The 5mg's will cancel out on both sides. Therefore, 3x plus a over 6a must be less than or equal to 1. Okay? Exactly. We want to find the restriction for x, the maximum possible x value, as AP. Wherever we put our block is P, so distance away from A will be x. Okay? So we just have to rearrange this to find x. multiply over by 6a. So we have 3x plus a must be less than or equal to 6a. Take away the a, so 3x must be less than or equal to 5a. Divide over by 3, x must be less than or equal to 5a. So the distance that we can put our block away must be less than or equal to 5 over 3a. Anything more, and that tension will become too much, the rope will snap. So that's what we say. So the block can't be any further than 5 over 3a away, further than 5 over 3a from our wall, from point A. Otherwise, the rope will snap due to tension being larger than 5 mg. Is P closer to B? Yes, okay, let's literally, in these mechanics questions, if we're stuck, let's just think about it. That tension in the rope is holding up our, was it a plank, whatever it is, right? The more weight we have where our rope is trying to hold up, because of the moments, I guess you could think about it as the moments, it's going to be having to hold up more, right? If we have loads of stuff close to the wall, it's not going to be having to hold up as much near it. Sometimes it's good just to think about it logically, right? If I have loads of stuff here, I put loads of stuff on my hand over here, there's a good chance this rope is going to have to be doing more work. Whereas if we have loads of stuff close to the wall, which also has that vertical force, the rope won't have to be doing more work. It will be a lot less work. It is to do with the moments equation, but just thinking about it logically can also help. Sometimes thinking about it both ways will give you the correct answer, will be that which will be more likely. You can think about the friction as well. Like that, sorry. In the ladder questions, same idea with this logic stuff. Don't look stupid in the exam. Or you know what, who cares? Look stupid in the exam if you want to. Yeah. Just using your arms with a pen, with a calculator. Cool. Okay, where are we? So we've done hinges, we've done ladders with a peg, we've done projectiles. Do we want another, guys? What question do we want? Do we want rigid bodies, connected particles, resolving forces, or position vectors? I think I'm going to go through it all. I'm going to do quite a long stream today. Then I'm going to go back in the evening to make sure the stream is a good quality. I might save some of these questions for later potentially. Let me know what topic, guys. More rigid bodies, connected particles, resolving forces and friction, or position vectors. Let me know. Let me know. We have done projectiles. I can put the question up if you want it. We have done projectiles. Position. Oh yeah, position vectors. Classic, absolute classic, guys. This is a tough question. Very tough question. Yeah, projectiles was the first question we did. If you want to look at that on the recording, this recording will be available. Why is my arm always broken? It's not broken right now. Okay, guys, I'm gonna leave this question up for a second. Projectiles was question one. Calm, watch that. Awesome. Yeah, I hate vectors too. To be honest, it only gets worse, guys. I'll tell you that now. It only gets worse. I've chosen all of my modules to avoid vectors. Essentially, any like mechanical stuff I've avoided doing all the stat stuff. All right, let's go through it. Relative to a fixed origin O, the horizontal unit vectors I and j are pointing east and due north respectively. So I is our x's and j is our y's. That's what we care about. Two particles are moving with constant acceleration. Okay, this is good that they tell us this. On a horizontal surface where O is contained. At time t equals 0, one of the particles is at the point with position vector 7i plus 2j meters. Or I would recommend in these questions, guys, writing them out as column vectors makes it a lot easier. Moving with velocity I plus 2j meters per second and constant acceleration a quarter I minus a half j meters per second squared. At time t equals 0, the other particle is at the point with position vector I minus j meters, so that's 1 minus 1. Just we're going to translate it all in a minute. Moving with velocity 2i minus 2j meters per second and constant acceleration half I minus a quarter j meters per second. Okay? Calculate the distance between the two particles at the instant, okay, when they are moving in parallel directions to one another. So what are we thinking, guys? What are we thinking with this question? We're trying to find when they're moving in parallel directions to one another. So first of all, before we even think about the distance between the two, we need to find the time when, at the instant, when are they moving in parallel directions to one another. To be in parallel directions, the velocities must be scalar multiples of one another. Okay, so one must be a scalar multiple of the other. Same thing as your pure maths, guys. One must be a scalar multiple of the other. Exactly. Child's play. This is child's play. Oh, okay. Fair enough. All right. Let's do it. So we want to find the distance between the two when velocities are parallel. first we have to find the time when they are parallel. Okay? So we're going to use v equals u plus at. What do we know for each particle? For the first particle, well, let's say we had that initial velocity to be I plus 2j, so that's going to be 1, 2. The acceleration to be a quarter minus a half. Okay? So we put that in. A is 1, 2 initial velocity, and the acceleration is a quarter minus a half. For particle B, we know the initial velocity is 2i minus 2j. That's going to be 2 minus 2. And constant acceleration, half minus a quarter. Okay. So from here, we're going to find the final velocity of each by using v equals u plus at. The idea is we're trying to link the two by time. We don't think about linking the two by any position vector or s because we aren't asking when are they in the same location. We're asking when are they when is the velocity parallel? Okay. If it was about location, then we're going to be thinking about displacement. But because we're not thinking about the position of the two, we're thinking about when they're moving parallel. Set v as a constant, then u plus at for each to calculate t. Exactly that. So we do our u plus at, plug in our u for each one, plug in our a for each one. So we have 1 plus a quarter t, then 2 minus a half t as our velocity of a, dependent on t. Then velocity of b, same idea, 2 plus half t minus 2 minus a quarter t. So what we're doing is v equals u plus at, and we have these expressions. To be parallel to one another, one must be a scalar multiple of the other. So this 1 plus a quarter t, 2 minus half t, must be equal to k times 2 plus half t minus 2 minus a quarter t. Okay, so this must be the case, right? So what we're going to do is split it up into each component. So therefore, our x, or essentially the east-west direction, the i's, 1 plus a quarter t must be equal to k times 2 plus a half t, then 2 minus a half t equals k times minus 2 minus a quarter t. Okay, guys, put any questions in because the chat is very slow. If you have any questions, I'll answer them as we get to the end. So what we can do here, we can make the k the subject of each one, and then we can set equal to each other. So we can divide over by 2 plus a half t on this top equation, and divide over by minus 2 minus a quarter t on this bottom equation. They both equal k. We can set them equal to each other to find t. I assume you guys can see we're going to have to form a quadratic. Okay, I did actually, this is all waffle, guys. If you're happy with everything, this is waffle. All I'm saying is when they are moving, the velocities are parallel, it's also like saying that the proportion of your I to your j must be the same for each one. So you could say that 1 plus a quarter t over 2 minus a half t is equal to 2 plus a half t divided by minus 2 minus a quarter t, but do not worry about that if you prefer it the other way, okay? By setting k the subject. Both ways work, you get the exact same solution as you go, sorry. So doing exactly that, we have our 1 plus a quarter t over 2 plus a half t equal to our 2 minus a half t over our minus 2 minus a quarter t, okay? So I've tried to make the working look a little bit clearer. It doesn't matter how you do it, guys, you will get the same answer. So I decided to multiply everything through by 4 just to get rid of these 4s in our denominators, okay? So we have 4 plus t over 2 times 4, 8 plus 2t. So we're just timesing everything by 4, guys, just making it clear. So we have 8 minus 2t over minus 8 minus t, okay? This bit is unnecessary. I decided to do it just because I didn't want negatives in the denominator. You would not, this is so unnecessary. I decided to multiply everything through by minus 1. I apologize. So we can just multiply either the numerator or denominator on the other side by minus 1, then either the numerator or denominator by minus 1, okay? So I just did minus 4 minus t over 8 plus 2t equals 8 minus 2t over t plus 8. This is just habit because I don't like negative denominators. Don't worry about that, guys. From here, we're going to cross multiply. So we have 8 minus 2t, so multiply over by this 8 plus 2t to be equal to minus 4 minus t, multiply over by t plus 8. So we get minus 4 minus t times t plus 8 equal to 8 minus 2t times 8 plus 2t. Just cross multiply. Expand these out. So expanding them out, minus t times t, that's minus t squared, minus t times 8, minus 4 times t, so we're going to have minus 12t. Then we're going to have minus 4 times 8 is minus 32. Then expanding out the right-hand side here, actually the difference of two squares, if you can spot it, we're going to have 8 times 8 is 64, minus 2t times 2t, that's going to be minus 4t squared, and then we're going to have minus 2t times 8, that's going to be minus 16t, but then we're going to have 2t times 8, which is plus 16t, those two cancel, okay? So we have minus t squared plus 64 on the right here. Then what we can do, add over the 4t squared to the left, gives us 3t squared, we have minus 12t, and then minus 32, take away 64. So we have 3t squared minus 12t minus 96 equals 0. What can we do here? Plug it in the calc, yeah? I decided to divide everything through by 3, just so because I was doing it in my head at the time. So we had t squared minus 4t minus 32. Factor it out. Do not worry about this. I'd recommend just putting this into your calc. You get two values for t. T equals 8 and t equals minus 4. This is a negative time. T minus 4 is a negative time. So what do we care about? We only care about t equals 8. That's the only viable time. So when are they moving parallel to each other? When the time equals 8. Amazing. So we have the time equals 8. Now, what do we care about? We care about the distance between the two. So when the time equals 8, we want to find the position of each one, and find the distance between those two positions or locations, however you want to say it. So exactly that, we find the position of each when time equals 8. What do we use? Well, our position vector will be our original position plus ut plus half at squared, because we have a, we have t, and we have u. We're given the initial, we're given the time now to be 8, or we found out it was 8, and we have our acceleration, which was also given in the question. But remember, we have to add it on to our original position. Okay, because we have our original position plus whatever more happens with our velocity, time, and acceleration. Okay? So this is like saying s equals ut plus half at squared. I put it as like r, I guess, right? Just to have that position. I mean, sorry, my r with my line under is just saying this position vector. Okay? So the original position for our particle A, going all the way back up, guys, original position to the question, we're told was 7, 2. For our particle 2 was 1 minus 1. And then we have the initial velocity, u, and then we also have the acceleration for each one. And then we also have the time. So all we have to do is plug all of these in, guys. Guys, give me a thumbs up if everything's making sense. Smash subscribe if you hate vectors. Okay, so from here, just plug in everything we know, guys. Plug in everything we know. So we have 7, 2 plus 1, 2, that's the initial velocity, times it by 8, plus a half times a, acceleration was a quarter minus a half. Remember, this is our I component, this is our j component. Times by t squared, 8 squared. Not going to waste your time, put it in the calc. This gives you 23 over 2. Exact same thing for our particle B. We take our original position plus ut plus half at squared. Original position was 1 minus 1. We add our initial velocity, sorry, which was 2 minus 2, times it by t, which is 8. Half at squared, we know that acceleration is half minus a quarter. T is 8 once again, so 8 squared. Not going to waste your time. Plug it in the calc. This is 33 minus 25. Okay? So what we have to do now is the distance between the two. We have the position vector of particle A at time equals 8 when they are moving, or the velocity, sorry, are parallel. So moving parallel to one another. And then we also have it for B. So what is the difference in our I components, or our X components, if you prefer it like that? Between 33 and 23, the difference is 10. Then the difference between our Y components, so we have minus 25 and 2, that's going to be a difference of 27. So to find the magnitude, or the distance, sorry, we're going to do distance in X's. This is just Pythagoras, guys, which is 10 squared, plus the difference in our Y's, or J's, which is 27. Square each term, add them together, take the square root, with the square root of 829, which gives us 28.8 meters. We are in mechanics, 3 significant figures. Hope that will make sense. Hope that will make sense. Let me know if we're all happy, guys. Let me know if we're all happy. Let me know, let me know, let me know. Make sure the stream hasn't crashed or anything like that. Okay, looks like we're all good. Why? What does the second R in RB? The second R. The second R. I don't think I meant to put a second R. Yeah, it wasn't too bad. This is a nice vector question. That's good. I guess there's not meant to be a second R here. This is just saying this is our original position vector of A, original position vector of B. Okay, that's all it is. This is the original position, and then we add on essentially the change displacement from there, the change position from there. Exactly, it's the original position. Yeah, these are the original positions because you have to add that on to our then displacement from our original. Okay, because we want to find the actual position vector relative to the origin. So we can find the displacement, then we also need to do it relative to what we originally were from the origin. When we add those two together, we get the final position. Awesome. Awesome. Okay. I may save a couple of these questions for later. Do you guys want? I reckon we do one more. We'll do 5 questions, yeah. Do you guys want Actually, might do a couple more. What do you want? Static rigid bodies, connected particles, or resolving forces with a bit of friction? Let me know what you guys want. Let me know what you want. Connected particles, it's going to be a pulley question. We haven't seen that in a while in an exam. Resolving forces with a bit of friction, it's going to be this question here. Interesting question with the least possible tension of the rope. Quite interesting. And then the other one is. Oh no, we did the position vectors. Oh yeah, the other one is the static rigid bodies with a ladder. I might save one of these for the evening, just so we don't go too long for now. Rigid bodies, electrical with string breaks. Yeah, I do have. Oh, I'm seeing a bit of both. I'm seeing pulley. I'm seeing more pulley now. Let's do pulley. Let's do pulley because we did two rigid bodies already. You know what? I'll prepare another hinge question for the evening. We're gonna do stats and mechanics in the evening. Pulley. Let's do pulley. Let's do pulley. All right, guys. I'm sure you've seen questions like this before, but it's good practice. Very relevant for the exam. Very, very relevant. Okay. Two particles A and B of respective masses, 2 kilograms and 5 kilograms, are attached to the ends of a light, inextensible string which passes over a smooth pulley P. The two particles are held at rest at the same level. They're at the same level above the horizontal floor, with the proportions. Oh, sorry, with portions of the string not in contact with the pulley vertical. Fine. The system is released from rest. So a little bit of waffle there, but we have some key things. We have masses of 2 and 5. Therefore, immediately, guys, what am I thinking? We know we're going to have 5g going down from B. That's the mass times acceleration. And the force going down from A will be 2g. Okay? Let's think about it, guys. Let's think about it. For the period B, for the period before B, sorry, reaches the floor, calculate in any order the acceleration of the system and the tension of the string. What do we do in these kind of questions? What do we do in these kind of questions? F equals ma at both particles. It could be a box and a particle. You know what? I'm going to upload the box and a particle question video if you guys are curious. But for two particles, F equals ma at each. Okay? The key thing is, which way are we going to be accelerating? The only difference between this whole system is that B, sorry, is heavier than A, right? B is 5, A is 2, so we're going to be accelerating with B going downwards. Simultaneous equations, F equals ma each, and simultaneous equations, we're going to be able to find T, we're going to be able to find A. So let's do it. So here's our diagram, guys. Remember, we have that tension in the string going against each of the forces. We're going to be accelerating with B smashing down because it's heavier. Okay? So connected particles, we're going to be using F equals ma on each. So let's look at each one. The key thing is the direction, right? The way which we're accelerating in. Because B is going down, we're going to have 5g being the dominant force, pulling us down, sorry, or pushing us down. It's going to be take away T, right? Because that tension is trying to resist us from going down, right? Always struggling from the way the tension goes. The way the tension goes, so it's always going to be pointing up against the weight of our two particles. But the key thing is to understand which direction we're. So if it goes down, it's going to be minus T because that tension is trying to stop you from falling. You have a force which is pulling you down, that tension is trying to stop you, right? So it's this force being dominant, tension trying to stop you. Whereas with A, the tension is bringing A up because we're accelerating that way. So the tension is bringing us up, but that 2g is trying to that 2g is trying to reduce it. Maybe explain how the tension works a bit more. It can be confusing. Like, is it the same in both roles? Remember, guys, the tension will be the same. Light and inextensible. What is light and inextensible telling us? It's telling us two very key things. It tells us that the tension will be constant throughout the string. So everywhere in our string, the tension is going to be the same. If we find T, that's going to be a tension wherever our string is. That's what light and inextensible is telling us. What else is it telling us? It's also telling us that the acceleration is going to be the same throughout the string. If one particle is accelerating up, the other particle will be accelerating down by the same acceleration because of that condition. Thumbs up if all of that made sense about tension and acceleration. I hope that made sense, guys. I hope that made sense. So those are two very key points. F equals ma, we know because of direction, because one is heavier, which way the tension will be working, the simultaneous equations, and we know because it's light and inextensible, that the tension will be the same throughout and the acceleration will be the same for both particles. Those are the key things you need to know for these questions. Hope that makes sense. Okay, so we have T minus 2g equals 2a. 2a is our mass times our acceleration. Acceleration we don't know, it's just a. Oh, Jesus Christ. Would we lose marks if we imagine it's resolving, so in that direction and B in down direction? If we imagine it's resolving A in the up. Um, I'm not 100% sure what you mean. I'm just gonna carry on, guys. So from here we have two simultaneous equations. We can see we can add the simultaneous equations to get rid of our tension. So we can just have the one unknown to be A. So, okay, sorry. Add the simultaneous equations to get rid of T to find A, right? So we add them together. We have 5G, take away 2G is going to be 3G, 2A plus 5A. So that's minus 2G plus 5G, which is 3G. Then 2A plus 5A is 7A. We're trying to find A. Divide over by 7. We have A equals 3 over 7G. 3 over 7G is just going to be 4.2 meters per second squared. Which part of the light inextensible means acceleration and tension will be the same? Exactly that. Light means the same tension, inextensible means the same acceleration. That's exactly that. Perfect. Okay, let's carry on here. So we have our acceleration, guys. All we have to do with our acceleration is plug it back into either equation to then find our tension. Sorry I was going slowly, I just wanted to go through that very carefully and answer any questions. So now we just plug it back in. This t minus 2g equals 2a looks easier. So we know what a is to be 4.2. So we plug in that a equals 4.2, add over the 2g. So our tension in newtons, it is a force, is 2 times 4.2, the acceleration, plus 2 times g. So our tension is 28 newtons. Awesome. Okay, let's move on to part B. So we found tension and acceleration. Part B, definitely the harder bit. I'm sure you guys have seen questions like this before. Eventually, B reaches the floor, 0.5 seconds. We have a time, 0.5 seconds after it's released and does not rebound, sorry. In the ensuing motion A, in the ensuing motion, A does not reach P, sorry. Determine the greatest height of A above the floor. The greatest height of A. So what are we thinking? The greatest height of A. So we're already some distance above the ground. So we're already that height. B will go down. So A will go down by the same amount. This tells us two things. If we can find the distance that B traveled down, A will go up by the same amount. And it also tells us the original height that A was. Because we knew that A and B were at the same height. So if B crashes down into the floor, that would also be the height they were originally up. So we have the original height plus the height that B drops. So that's original height times 2. And then we still have another height that we have to consider. Write it in the chat, guys, while I explain through this part. Yeah, Robbie's on it. Robbie is on it. Robbie's on it. All right, let's go through it. Okay, so write down what we know to find the greatest height of A. First of all, there's two things that we need, guys. So after we find that original distance that B smashed down, so it tells us that original distance we were hanging and that A goes up, we also need to consider once B smashes, our particle A will then be under no tension. No tension at all because that tension is gone because B smashed into the ground. So what do we consider? We consider the velocity that A is traveling out when B stops moving into the ground, so it hits the ground. Consider that velocity. It will then kind of go up. String will be taut, so we're moving freely under gravity. Exactly, we're moving freely under gravity. And we have to find when it stops moving upwards. So when that final velocity becomes zero. But let's go step by step. Let's focus on the first part, where the distance traveled by B when it hits the ground, as this tells us how high up A was originally. So these are the 2 points, sorry. So we're going to eventually have to find the final velocity of A and B when B hits the ground. And we're first, yeah, I'm seeing you guys are perfect, yep. And then the distance traveled by B when it hits the ground, as this tells us how high A up was originally. Let's focus on the second arrow first. So we're released from rest at the start, okay? To find the displacement, we can use S equals ut plus half at squared to find the final velocity, which we're going to have to use to then find when A is acting freely under gravity. But let's get there in a second. What do we know? Initial velocity 0, because we're there at rest at the start. The acceleration is 4.2. We found this in part A for the acceleration to be 4.2, and our time is 0.5. We have U, A, and T. We can find both V and S. Using V equals U plus AT, well, our initial velocity is 0, so both of these U's will become 0. And then acceleration is 4.2, T is 0.5. 4.2 times 0.5, our final velocity, once B hits the ground, is going to be 2.1, okay? Now looking at displacement, so U times T is 0 times T, don't worry about that, plus half times AT squared. Half is 0.5, I just wrote it as 0.5 times 4.2 is the acceleration. T squared is 0.5 squared. Exactly, the final velocity will become the initial velocity once we're acting freely under gravity. So we have our displacement for B will be 0.525, okay? Or the way displacement of A going up. Remember to be consistent with your accelerations and your displacements. Because I kept my acceleration positive and my displacement positive, this would be for A going vertically upwards. If one was negative, one was positive, then that'll be for B, okay? But don't worry too much about that. Just plug in these numbers and you get exactly what you need, okay? So from here, we have 0.525 meters was the distance that we had to travel downwards there. Okay. Therefore, they were both originally hanging at zero point 0.5. Shouldn't really put hands like this. Originally hanging at 0.525 meters. Okay. So once B hits the ground, the string goes slack. Now A is moving freely under gravity. So this final velocity is actually our initial velocity for considering when we're moving freely under gravity. So we have to use that to find the maximum height for A. So we want to find the additional displacement up. Our initial velocity will be this 2.1. This final becomes the initial. I'm seeing everyone, yeah, wags perfect. Okay, perfect, perfect, perfect. Then the acceleration now, we don't have any of that tension. It's just going to be gravity. So we have U, we have V, we have A. We want to find S. We know that V squared equals U squared plus 2AS. This connects all of them. Because we don't know the time is irrelevant. So exactly that. 2.1 the initial, 2.1 squared, plus, so we have minus 9.8 to be gravity, multiplied by 2, then we have S. So 4.41, sorry, take away 19.6 S will be equal to 0. We can add over that 19.6 S. So 19.6 S will be equal to 4.41. Divide over by 19.6, we get that additional displacement once the string is slack. Oh yeah, sorry about that, Fred. Once the string is slack, is 0.225 meters. Okay? So what do we know? We were initially already, because we're trying to find the maximum height, we were initially that 0.525 meters. We go, okay, I'm just going to do it, guys. We go further 0.525 meters up, and then once that string is slack, so we're freely under gravity, I kind of imagine it like this now, we go up another 0.225 meters. So we have to add all those three together. So there was our initial, originally 0.525. We go further 0.525 as B goes downwards. Remember, guys, we're not hitting our pulley. We don't have to consider it hitting our pulley. Then 0.225 more as we found once it's slack. So the maximum height, we add all three together, 1.275. A lot of people forget to add on this original height, okay? So make sure to add the original height. Because the maximum height above the ground, we have to consider what it originally was. Thumbs up if that makes sense. Thumbs up if that makes sense. Smash subscribe and all that. I'm gonna make sure the stream is good because my Wi-Fi has been cutting off all day today. Looks like we're all good. If it asks displacement, would you leave out the original? If it asks displacement, you would leave out the original. Yes, the maximum displacement. So you don't consider that original height above the ground because you just care about. I'm just doing it. You just care about um from where it was originally. So you wouldn't care about the ground. You just care about how it changes. Yeah, a lot of people forget. Yeah, it does not hit the pulley in this case, guys. It does not hit the pulley. It tells us in the question. Okay, it says A. What was it? What was it? What was it? Blah, blah, blah. I think that's am I blind? Oh yeah, okay. Ensuing motion A does not reach P, right? So we don't reach the pulley. It tells us in the question. Okay, you may have to consider if it hits the pulley, for example. They may ask you something like that. I've seen very like many different variants of this question. Okay, so guys, I'm probably gonna go for one more maybe, and then do the other one in the evening. I'm gonna do more mechanics as well in the evening, but I'll just save one of these now. Actually, that's just my. Do you guys want to do the rigid bodies or resolving forces and friction? Let me know. I'm seeing thumbs up. I'm happy to see those thumbs up. Why do we add original height? Can H explain that? Oh wait, I didn't mean to pin this comment anymore. Unpin. Okay, cool. Chat's been coming for me. Just give me a second, guys. Okay, when the cubic equation. Okay, this is just some random stuff. You add original height because you were trying to find. Yeah, okay. S perfect. Yeah, because we want the greatest height of A above the floor. Above the floor, guys. Okay, we're already this original height. Then we have to consider the displacement when we count the tension in the rope, so B smashing down, and then a little bit more. Rigid, okay, yeah. You guys asked rigid before, let's go rigid. Okay, so we've done two rigid bodies already. We've done a hinge question. We've done a ladder on a peg. This is a very similar hinge question, but it's good practice, guys. Sorry, a rigid body question, so it's good practice. So let me go on one note to make my forces very clear. Where are we? Where are we? Where are we? There we are. Okay. So here's what we have, guys. A uniform ladder AB of length 6 meters and mass 20 kilograms is placed. So uniform ladder, like before we even start, guys, uniform ladder, mass 20 kilograms. If you were trying to find displacement on that previous, okay, did they ask about rebounds for the question? As far as it goes, I'm pretty sure this is as far as it goes. These are from harder questions, so the rebound thing would be a little bit too hard. I haven't seen a rebound question. Let me know if you guys have seen a rebound question, but I don't think that is relevant for A level. So yeah, so immediately I'm seeing, so let's go with rigid bodies. I'm just gonna go through this. Wait, one last question. Displacement, it would just be, so we had that original one was, we don't care about the original height in that case. We just care about the further up it goes because of B going down and when it's slack. So that would be the 0.5 something plus the 0.2 something without the original 0.5. Okay, so let's go through this, guys. Uniform ladder AB, length 6 meters, mass 20 kilograms. Uniform ladder, center of mass will be in the center. It will be halfway between A and B. We know the total length is 6 meters. So immediately I'm thinking 3 meters away from A, I'm putting on this 20g, right? Mass times acceleration is our force. So acceleration is gravity, 20 times gravity. 20g, 3 meters away. Okay, we know that already. Cool. It's placed with its end A on a rough horizontal ground. Rough horizontal ground. What am I thinking as placed on A? Let's just do it like this, yeah? Rough horizontal ground. We don't know that it's going to be mu r just yet, but we will eventually. I'm going to highlight it now, but we will eventually. But we know on this horizontal ground, we're going to have a reaction force. So that's what we currently know. So from here, rough horizontal ground and B over a smooth vertical wall. Okay, so there's no friction on the wall. The ladder rests on the wall at point C. Okay, we have point C here. So that BC, the distance of BC equals 1 meter. So we can write on that 1 meter already. The ladder is inclined at an angle of 60 degrees to the horizontal, and the coefficient of friction between the ladder and the ground is mu. They're telling us the coefficient of friction, so I'm already thinking the friction is going to be mu times r, but let's confirm that. When a man of mass 80 kilograms is standing at point P on the ladder, such that AP equals 4, we can draw that on already. So that's 80 kilograms as the mass, so we can have 80g. It's going to be 4 away from A. So 3 plus 1 is going to be 4. So we can draw down that vertical down force. Remember, guys, these forces are vertically down, okay? We starting at point P on the ladder, so the distance AP is 4 meters. The ladder is in limiting equilibrium, limiting, point of slipping, what else is it, tilting, or moving if you're a particle, friction will be at its maximum. When friction is at its maximum, our friction will be mu times r. Exactly like that, guys. Limiting equilibrium, friction is mu times r. So our force pointing in towards the wall is mu times r. So what about this, guys? How do we know which way our point of friction is going? Just think about it. We have a ladder on a wall. Which way is a ladder trying to slip? Well, a ladder can't slip upwards. It's trying to slip downwards, right? If you have a ladder on a wall, it's trying to go like that. It's trying to fall down. Yeah, when you see people falling off ladders, the ladder goes like that. So our friction, to prevent it from going like that, will be pointing towards the wall. So that's why our mu times r is going towards the wall, okay? So what else do we have? What else do we have? We have to determine the exact value of mu. So it doesn't really give us much in this question. But what do we know about rigid bodies? Same formula every time. Yeah, they're gonna want us to find moments. They're gonna want us to resolve vertically, and they're gonna want us to resolve horizontally. They will ask you to do these 3 things in these rigid bodies questions. Wherever it's hinges, ladders, beams, rods, whatever they want. Yeah, it's always gonna be those 3 things, right? So first things first, I'm thinking this reaction force N from our wall, because our wall is going to exert a reaction force onto is it a ladder? Onto a ladder, right? We're going to call it N. So first things first, we're going to want to find this reaction force N. So we're going to take moments about A. Why are we taking moments about A? Why are we taking moments about A? It's so we can eliminate this R and this mu R, okay? Because we don't know mu and we don't know our reaction force just yet. So we can eliminate those. The only unknown will be N, and then we're going to be able to find N. So exactly that, guys, we're going to find the moments about A to eliminate this reaction force and mu for now, okay? So taking moments about A, we're trying to find the perpendicular distance times by the force. So see what is going clockwise and see what is going anti-clockwise. Going anti-clockwise, these will have to be equal because we're in equilibrium. Clockwise, what do we have? Sorry, anti-clockwise, what do we have? We have this 80g and 20g as the 2 forces. How do I know n acts diagonally? So when we have like a peg or whatever it is really, peg, ladder, wall. Um, think about it like this. We have our ladder resting against that wall here. This wall is not pushing it like this or just like this. This wall is pushing our ladder up like this. So it's going to be perpendicular to the plane of our ladder. We are going to have to find the vertical and the horizontal components because we're going to resolve vertically and horizontally eventually. But that reaction force, like with the peg, let's go back to the peg question really quickly, guys. Like with the peg, it's going to be perpendicular to the plane of our ladder, beam, or rod, whatever it is. Okay, so just think about it. It's not pushing up, it's not pushing across, it's pushing perpendicular because it's holding that ladder up. Okay, hope that makes sense. Give me a thumbs up if that makes sense. Right, so where were we? We were here. Okay, so we're trying to find moments. We're trying to find the anti-clockwise moment first. So we have to find the perpendicular distance to where each of these forces. So the perpendicular distance, let's start with 20g. So we're trying to find this distance here. Okay, perpendicular distance. We have the hypotenuse to be 3. We're trying to find the adjacent. So to find the adjacent, it's going to be the hypotenuse multiplied by cos 60, right? So whenever it's the adjacent, we're going to be using cos. Hope that makes sense. Okay, let's just go through this. Okay, I'll answer questions at the end. So 20g multiplied by 3 cos 60 because it's the adjacent and the distance is 3. So the perpendicular distance is 3 cos 60. So we have 20g multiplied by 3 cos 60. Same idea for 80g. We still care about this perpendicular distance to this force. So it's going to be 4, right? Because we have a total distance 4 on the hypotenuse. We care about the adjacent, so it's going to be cos 60. 4 cos 60. So we have 20g times 3 cos 60, 80g times 4 cos 60. Perpendicular distance to our clockwise moment now. So we're setting this equal to our clockwise moment. The perpendicular distance will just be 1 plus 1 plus 3. So that's going to be 5 multiplied by n. Because this is already perpendicular to A. Yeah? It's already perpendicular for. So our force N is going to be going like this. So the perpendicular distance will just be the hypotenuse here of our big triangle. That's just going to be 5. Hope that makes sense. So from here, we know the cos 60, we know we know cos 60 and cos 60 to be half. So we have 20g times 3, that's 60g, times by half is 30g, 80g times by cos 60, so that's 40g times 4 is 160g, 5 times n is 5n, okay? So we have 30g plus 160g to be 190g, equal to 5 newtons, okay? Oh, sorry, 5n, not newtons, 5n. Therefore, n, our reaction force, will be 190 divided by 5, 38g. So we have n. Yeah, exactly. It's so repetitive, these questions. So now, what have we done? We found moments, we found the reaction force n. We always want to find that reaction force first so we can eliminate these two, okay? Now we're going to resolve vertically and horizontally. Same pattern as always, okay? There we go. Right, so exactly three things we always do: resolve vertical, resolve horizontal, and moments. Normally the moments is first so we can eliminate certain unknown forces, okay? So we have n to be 38g. What do we want now? We want horizontal and vertical. But before we start, we're going to have to split our n reaction force into components. Our vertical component and our horizontal component. Let's think about it, guys. Let's think about it again. So once again, we have our vertical component and we have our horizontal component, okay? We know, what do we know, guys? What do we know? We know this angle here is going to be 60. Why do we know this? We know this angle here is 90. Same idea as before. This angle here is going to be 90. So the whole triangle is 180. So we do 180 minus 60 plus 90. This is going to be 30. We know this is a 90-degree angle. So this has to be 60. 30 plus 90 is 120 to make this straight line over here equal to 180 because this whole thing is a straight line. This angle must be 60. So that's how we know it's 60 in case you guys are curious about how we know that that angle is 60. So then from here, because we know this is 60, the opposite will simply be n. So opposite to our angle is going to be n sine, and then adjacent is going to be n cos 60. Okay? Hope that makes sense. I hope that makes sense. So let's continue on. So there we have it. The one adjacent to our angle is n cos 60, opposite is n sine 60. Now we can resolve vertically and horizontally. So you saw the answer there, but let's go through it step by step. So just trying to make the highlighter. Okay, so vertically, what do we have? We have r plus, remember here we had this n sine 60, so this is a sine one, n sine. So it's going to be r, n sine, what do we have going downwards? It's going to be 80G plus 20G. So it's going to be 100G equal to R plus n psi. Then looking horizontally, guys, what do we have? We have this. Sorry, this is going to be n cos, guys. I apologize. It's going to be n cos. Almost made a mistake there. I made a little mistake. N cos, because it's the adjacent one to the angle, sorry. And then going horizontally, we're going to have the n sine. And the only thing opposing that will be this mu r. Okay? So the verticals, we're going to have r plus n cos 60 equal to 100G. Then we have mu r equal to n sine 60 for the horizontal, I believe. That's it exactly, yeah. So n cos 60 plus r equals 100G, then n sine 60 equals mu times r. We already know what n equals though. We know what n equals. So the only unknown here right now, besides mu, which we're trying to find, is r. So if we can find r, we have n, mu will be our only unknown. Okay? So what we can do, using the second equation, we're going to rearrange it to find r to make the subject of a formula. Because if we can have r in terms of just n, then there are no more unknowns. Okay? So no more unknowns. Divide over by mu. So we have that r equals n sine 60 over mu. This is perfect as we know n and we want to solve for mu. So plugging in this value of r into our resolving vertically equation, so we have n cos 60 plus n sine 60 over mu equals 100G. To get rid of that mu on our denominator, we're going to multiply the whole thing through by mu. Guys, keep giving me thumbs up if this makes sense. I just want to make sure everything is making sense. From here, we're going to multiply through everything by mu just to get rid of the denominator. So we have mu n cos 60 plus n sine 60 equals 100G times mu. Okay, we were trying to make mu the subject of the formula. We're going to get all the mu's to one side, factor it out. So take away mu n cos 60, and then factor out the mu. So we have mu times 100G minus n cos 60. Okay, so n sine 60 will be equal to mu times 100G minus n cos 60. Lovely, Oscar. So we know that n equals 38G. Okay, simply by plugging this into the calculator. Yeah. Oh, sorry, no, sorry. From before, we know that n equals 38G from part A, where we all from the moments. And then what we can do, making mu the subject, we can plug in that 38G for our n's. 38G sine 60 equals mu times 100G minus 38 cos 60, 38G cos 60. We can actually cancel every G from the left and the right. Bing, bing, bing. So we have 38 sine 60 on the left, and then to find mu to make the subject of a formula, we can divide by 100 minus 38 cos 60. Oscar's so on it. So then we have 19 root 3 over 81. If you want this not as a fraction, as they tend to want in mechanics, three significant figures, it's always three in mechanics, three significant figures, be 0.406. But if they want the exact value, then they will ask for the exact value. If in doubt, guys, right, yeah, exact value would be the fraction. So it would be 19 root 3 over 81. For some question, I've seen reaction forces at angles of those horizontal. If it's for rigid bodies, yeah, if it's a particle, for example, then we care about the perpendicular and the parallel forces to whatever plane we have. In that case, we don't find angles. Oh, so we don't find components. But if it's rigid bodies, if you find a rigid bodies question that isn't just vertical horizontal, send it over. I'll definitely want to go through that one for sure. But if it's some kind of like force pushing on a particle and it's already perpendicular, then you won't do that. So it depends. It depends if it's a rigid body question or if there's something else. Rigid bodies, if we're just caring about the ladder, the rod, the forces acting on that, that's when we split it up into vertical and horizontal. I do have a question like this, guys. Do we want this question as well, or we save it? Okay, I saw it in a pulley. You didn't have to. Oh, in a pulley. So you saw it in a pulley. Oh yeah, pulley. Okay, so there's going to be particles involved. For some question, I've seen reaction forces at an angle to the surface. You don't have to find the horizontal and vertical components. Yeah, no, I assume you mean if it's a pulley, then there's going to be something connected, and then when you have two particles, you do your F equals ma. Save it. Okay, I'll save this question. I'll save it. I'll save this question to start on the next stream. Perfect. All right, guys. One of you asked for projectiles, so I'm just gonna leave the stream up for 1 more minute. I believe there was a question before. You know the hinges question where there was a reaction force from the wall. So when do we add a reaction force from the wall? So with the hinges question, we were hinged at A, right? So this hinge is actually pushing our rod up or downwards to counteract that rope pulling it up or the rod being too heavy. Okay? So that's why we had a reaction force there. If it was a wall, we care about the reaction force if there's friction. Anytime we have a hinge or anything there, you're gonna have a vertical and downwards, yeah. Okay, cool. When it's 8 p.m. later, we're doing more mechanics and we're gonna do loads of statistics as well. Okay? If you want, I can find one where we have a rough wall or one where we potentially have a being just lent on the wall and we have to determine the forces on that point. I can go through that later if you want. Because everyone likes rigid bodies. In the hinges question, there was no reaction force from the wall. With ladders, there is. Isn't maths, but do you think it would be a good idea to do some camp paper free? Do maths today. Do maths today. I'd say just do maths. Me personally, the day before an exam, after midday, I wouldn't do any chemistry. After like lunch, I wouldn't do any chemistry. Personally, that's just my opinion. So we are done, guys. We are done for today. Yeah, Fred. I reckon later I might show them side by side. Because if I explain it, it's going to be me going like this and explaining. If I can get the image of that, comparing a hinge to a ladder, I'm definitely going to go through that. Just to make it really clear, like showing why we have something going up, why we have something going down on the walls and on the hinges, and just comparing. So I think I will go through that later for sure. So guys, we are going to end it there. I hope I see you guys later at 8 p.m. Cheeky 1.5 hour stream, nothing crazy, nothing 12 hours like Neil does maths. I would recommend this stream for mechanics. Mechanics is quite good as well. I mean, I like to explain it the way he explains it, so definitely helpful. But yeah, guys, I think that's it. Yeah, Chem Paper 3 I will not do after. So guys, I appreciate that. Fred, I will visually show why we have certain reactions on hinges and walls later on, because I think that'll be the best way for me to explain it. I don't want to be just to be starting waffling about reaction forces. I would make more sense if I show you it in diagrams. So guys, just give me a thumbs up if you're all happy, and I think I'll see you, or hopefully see you guys at 8 p.m. Right, looks like we're all good. I forgot my chat is 2 minutes delayed. Okay, cool. Cheers. Okay, guys, appreciate that. I'll see you at 11, and Fred, I will address everything I can later on.